Hi, welcome to an audio test session with APX. These videos provide worthwhile information for APX users and demonstrations on a range of audio measurement applications. In this session, Joe demonstrates some of the APX production test features.
To demonstrate these features, we'll be using the small headphone amplifier shown in this photo as a device under test, or DUT. This device makes an ideal DUT because it is small and simple to set up, and it has some interesting features from an audio test perspective. The product's logo has been covered in the photo because the intent of this video is to demonstrate production test features, not the performance of the device. This headphone amplifier is battery powered. It has one analog input and two analog outputs, presumably so two headphone users can listen to the same content simultaneously. Controls and indicators on the device include a knob that doubles as a rotary on-off switch and a volume control, an LED that turns blue when the battery charge level is adequate and red when it is not, and a 3-position slide switch for the bass boost or equalizer feature with settings of flat, M for medium, and H for high. Here's our demonstration for the headphone amplifier test. As you can see, we're running in production test mode right now. We have the simplified user interface here in front of the main APX UI, and it has two main buttons on it, Test Output 1 and Test Output 2. These correspond to sequences named with the same name in the project file. Let's go ahead and run Test Output 1, and then we'll run Test Output 2. We'll then exit out of production test mode and break it down. Alright, so here we get a prompt to enter the product ID of the device under test. I'm just going to type in ABCD999. Next we get a prompt to scan the barcode of the device under test. I don't have a barcode scanner here, so I'm just going to type it in with the keyboard. 1234001. Next we get a prompt telling the operator to switch on the device under test, to insert the cable into the headphone output jack 1, set the boost to flat, and to adjust the gain. So I've just switched the unit on, and you can see here we're watching the gain increase towards the target as I increase the volume control knob. And once I get into the target zone of plus or minus 1 dB, the colored bars change color, indicating that they're within limits. Once I've adjusted the gain, I can dismiss the prompt by clicking OK. Next, I get a message telling me that the system will set the generator level to the level required to produce 1% THD plus N. This is a regulation step using the auto set generator level feature. When it's finished, it'll progress to the next step. This is a pass-fail step, which is just asking the operator to verify that the LED on the front of the unit is the correct color. It is, so I'll collect pass to keep going. Next, we're running a level and gain measurement, comparing it to limits. Then a distortion measurement, THD plus N. Next, we measure a frequency response with the flat boost at 1 volt RMS, and the same measurement at 1% THD plus N. For the next step, we want to measure the frequency response with the boost set to M for medium, so I've got a prompt to set the boost to M. Once the boost is there, I click OK to continue, measure that frequency response, and the next step is the same for the H position. I switch the DUT to the H position and click OK to continue. Now, as you can see here, the system is progressing, and I get an indicator on the user interface every time the sequence is passed. Now, what's happened here is it's automatically stepped to the next device under test because I've told it to do so. The other thing that you might notice is that the product ID field here is populated with the previous value. That's because I used the feature in the prompt to set this input to be persistent across various tests. Go ahead and set that and get ready to scan the barcode. I'll just hit 1234002, continue, and so on. So the test carries on as it's doing now. So rather than keep going like this, I'm just going to cancel out of it so that we can carry on with the demo. So you'll notice when the sequence has been canceled by the user, the progress bar gets this red notification saying it's been canceled by user. At this point, we'll just end the sequence and go back to the main panel. Next, let's have a look at the Test Output 2 button. See what happens here. So we have a similar prompt. This time it's telling me to insert the input cable to the analyzer into input 2, and to set the gain. Gain setting is pretty much the same for the second output. Just adjust it a tiny bit and click OK to continue. Then we'll progress and measure the level and gain without doing the regulation step. Notice here that I didn't change the frequency response to flat, and it's caused it to fail the measurement. Here I will set the boost to the M position and click OK to continue. And next we'll go get a prompt to switch to the H position and continue with the measurement. So as you can see here, when I get to the end of the sequence, rather than going on to the next device automatically, it's been configured to just let the user do that manually. I'm also getting an indication that the sequence has failed, and in my list of measurements here, I can see the measurements that have failed because the EQ wasn't set to the correct value. Let's go ahead and end the sequence here, and we'll break out of production test mode and look at how this project file is put together. So to get out of production test mode, I can either press the unlock button, which unlocks the project, or the exit app. Exit app will simply exit the APX software. Let's try the unlock. If I type in the password, very simple password, and here I'm ready to look at the project. So let's go ahead and look at the sequence editor, and you can see here that I have two sequences, one labeled Test Output 1 and the other labeled Test Output 2. And these names, of course, correspond to the buttons that were on the front panel of my production test mode UI. I have the settings here that when the sequence, when all measurements pass, the sequence should run again automatically without pressing the next device, and set up for a number of retries. I also have selected the write variables and statistics to log file with a name of a file using variables. And let's just go in and look at some of these variables. So we have the folder is the project.dir, which is the folder containing the APX project file, followed by reports underscore the product ID. That's the name of the folder, and then the file name is Apx Sequence Statistics Csv. And if we look at Test Output 2, you can see that here we were set to have the sequence run again when the next device is pressed, not to automatically go to the next device. Let's close this and go and look at the way some of the other properties that we have here. So if I look at the sequence Test Output 1, you can see the collection of check boxes is different than it is for Test Output 2. If we go back to Test Output 1 and drill in a little bit, let's first look at some of the pre-sequence settings. So here we have the prompt. If we double click on this, we can open it and edit it or look at it. This is the prompt to enter the product ID of the device under test. We're assigning the product ID into this variable product ID, named product ID, and it is both required and persistent, meaning it must be present if I want to proceed, and the next time I run it will be set to the same value as it was before. We can also preview that. The next prompt is the device ID prompt. In this case, I've just got the text to scan the DUT barcode. In the appearance section, I've added a picture to make it clear for the user. And again, we can look at a preview of that prompt. If we look down at the bottom of the sequence, you can see the post-sequence steps. We have the report, and you'll notice that the report is checked here, but it wasn't showing up at the end of the sequence. So if we double-click on that, we can look at the properties of the report, and you can see some of the settings here. So what we've done is we've used the Auto Save tab, and we've set the report up to automatically save the report when the sequence is completed, but the Show Report checkbox is unchecked, meaning that it will be saved automatically, but it won't show at the end of the sequence. Here we select the format. We've just chosen PDF for this report. We've used variables, again the project dir variable followed by reports and then the product ID. We're using a prefix of HAMP and then the sequence name. And then we've set, if the report file exists, make a new file with a unique name. This second node here is the data output node that we discussed earlier. The way this works is if you select its properties, using variables, you can specify, again, the folder where the sequence data.csv file is saved. And let's go in and look at that folder. So if we go to, it's on the desktop here, PT demo, and that's the name of the folder we created using variables. If we drill in here, we see the APx sequence data.csv, and this is essentially just a CSV file that we can open with Excel. My Excel file doesn't open, Excel implementation doesn't open files automatically, so I have to do this extra step. This has the sequence run listed. We have the date and time stamp. The time will not be formatted correctly by default, but if I select time as the format, it'll set the time. Here you can see the device ID that's been filled in, a pass for the sequence, and then for every measurement that has a meter result, we get the name of the signal path and measurement and the channel, the upper limit and lower limit, and then for each run of the sequence, the measurement of that meter result. So this is a very nice way of logging the meter results as the project progresses and as you run multiple items. You can look at an entire day's or an entire week's worth of production using a spreadsheet like this. Now if we go back and look at that same folder, you can see the test reports here, and we get an indication, the product ID, the device ID, and then a summary field, summary area showing which measurements have passed, the entire sequence has passed, and all of our results that are present in the project, including the graphical results and the pass-fail indicators. We also have the APx Sequence Statistics Csv. Now this is generated because of the checkbox that we checked in the production test menu. And this keeps a log for every sequence run. Again, because of my Excel issue, I have to drag that folder in. So here we have a date and time stamp, the product ID, the device ID, the cycle count, the number of passed count, the failed count, and so on. So whatever statistics that I've set up to be logged in this file are recorded on every sequence run. All right, so let's go back and look at some of the other settings in the project file. Now in signal path 1, we asked the user to set the gain of the device, and in order to do that, we took advantage of this step called Make Result Visible. So this is a sequence step, a very simple one. You just give it a name and you choose the result that you want to make visible. So that makes the gain result active so that the user can set the gain. I've also checked this turn generator on step. This is a step that is available all the time, but it's unchecked by default because I want the gain to be on, I want the generator to be on so that I can measure the gain and have the user set it properly. Then we have the prompt to set the gain, and just as a preview here, this is the instruction that we gave the operator with the gain showing on the screen so that we could have him set the correct level. Then we have the result visible. We make the THD plus N ratio result visible. And then the very next step is a prompt that we're setting the generator to 1% THD plus N on channel 1. Now this prompt doesn't have any response, and it only shows for 2 seconds. So really this is just to advise the operator that we're doing a regulation measurement. And let's have a look at how we're doing that. It's not through a sequence step in this case, it's through the measurement sequence settings. So if we click on this node, we can see that for signal path setup, we have this checkbox, auto set generator level, and it's been checked. And this will cause the system to regulate and run the auto set generator level feature. That feature is available in the References tab down here under auto gen level. So it's been pre-configured in the project to regulate THD plus N ratio to a target value of 1% on a specific channel, being channel 1. And we have the start and stop value, the initial steps, and the frequency that we want to regulate at. So essentially we're telling the system to regulate to 1% THD plus N on channel 1. When that process is complete, if we look in the Verify Connections tab, the generator level is left at the value required to achieve the 1% THD plus N target. It also sets what we call the DBRG reference. This is the value of the reference now required to produce 1% THD plus N. Now that we've done that, if I go back to a measurement such as this one, where I wanted to measure the frequency response at 1% THD plus N, I can simply set the generator level in units of DBRG, 0 DBRG being the target required to get 1% THD plus N. That's a quick demonstration of production test mode and the production test features in the APX project file. Hope that you'll find some of these features useful, and thank you for watching.